Imagine reaching Mars in 2 months, not 2 years. No bone-thinning microgravity marathon. No endless radiation crossing. No fuel depots, no slingshots. No decade of patience. Just one engine, pulsing. It sounds like science fiction. But in 2024, NASA selected a propulsion concept that could rewrite deep space travel. Not warp drive, not antimatter, not fusion. A pulsed plasma rocket. And if it works, the solar system stops being a destination and starts becoming a route. Right now, getting anywhere in space is a slow death by mathematics. Chemical rockets are powerful, but inefficient. They burn hard, then starve. Ion drives are efficient, but weak. They whisper for years just to cross the outer planets. Nuclear thermal propulsion sits somewhere in the middle, promising, powerful, but still not enough to break the wall. Because every existing engine forces the same brutal trade: thrust or efficiency, power or patience, never both. That is the wall every Mars mission slams into. But the pulsed plasma rocket tries to break the trade completely. It uses rapid pulses of nuclear energy to superheat plasma, then fires that plasma out the back of the spacecraft. Not one continuous burn, not a slow electric whisper, a rhythmic, violent heartbeat of thrust. Each pulse delivers enormous efficiency, and the pulses come fast enough to produce real acceleration. For once, an engine could offer both power and patience. If it ever flies, the math changes. Mars in 2 months, the asteroid belt in a season, Jupiter within a single human career. Saturn no longer just a one-way bet on a robot's lifespan. Crewed missions become possible to places we currently only send machines and hope they survive. No more radiation marathons. No more muscle wasting for years in deep space. No more astronauts arriving at another world as weakened shadows of themselves. The human body could finally survive what the engines make possible. But there is a catch. The pulsed plasma rocket is nuclear. And nuclear in space is not just a physical reactor. It is a political one. Launching fissile material, containing radiation, cooling a reactor in vacuum, convincing the public, regulators, and governments that the future is worth the risk. There is no prototype roaring on a test stand, no spacecraft waiting on a launch pad, only diagrams, simulations, a NASA grant, and a possibility. The physics may work, but the politics may be the harder reactor to crack. For 70 years, humanity has crossed space the same way: chemical fire, fragile bodies, and decades of waiting. The pulsed plasma rocket suggests something different, not just a faster rocket, a new kind of engine, one that does not fight distance, it outpaces it. So here is the question. If the pulsed plasma rocket finally flies, do we use it to walk on Mars, or skip the red dust entirely and aim for the moons of Saturn?